I'm Jim Seekage, one of the HVAC instructors here at Pima College for the BCT courses here. And today we're going to do a little training video on this oil-fired burner. First of all, we have to have the proper protection equipment on. You have to have safety glasses, prefer cotton shirts, cotton pants, or fire-rated, flame-resistant. We're dealing with the number 2 diesel oil here. So things are, we're dealing with a combustible product here. So we want to be safe. Number 2 is you're not going to take apart anything on this working part of the lab. We want to make sure that if there's anything wrong with it, we'll have an instructor take care of it. And also, when you are working on this lab, you can't do it by yourself. You have to have an instructor out here at all times when you're doing the working part, the fire up part. Now we do have this lab. Before that, what you will take apart, we have an oil burner right here, and we'll take it all apart and look at over all the components so you get familiar with it. There's some things in here that are not related, so you'll have to ask your instructor. Now I'm just going to go over a little bit on this burner. This is a trainer, so we don't have an actual heat exchanger furnace with the flue pipe and also our stack control. Normally you would set the combustion air on this, as you can see all the indicators on here, with a combustion analyzer with your stack control to get the proper combustion. We're not going to do that here. We're going to show you how you can adjust this band on here to get more combustion air and less. Usually you'll have to have a very expensive combustion analyzer to do this for you, and if you're working on any type of combustion, especially oil. This is a number 2 oil, as I stated before, that's used on this particular operation. Now over here, this is our combustion air tube right here. It's new, it's a new part here. I'll show you the one we pulled out that was bad. It comes as a whole complete kit. As you can see, we had some issues with our retention ring here. It was pretty warped. Real bad condition. And that retention ring acts as an atomizer with the fuel nozzle. Has the combustion air as it sits into the ring, the holder there. You see how warped it is. So that combustion air is coming down, and we're atomizing that fuel through that nozzle, and we're getting that fire ring, I call it, or combustion taking place. This is our fuel tube assembly with our electrode assembly. As you can see, this one was bad. It was worn out, loose. The clamps are real tight. This is porcelain. We don't want to crack this, because if you tighten it too tight, it'll crack. I've done in the field where I put spacers in there temporarily when it's real loose until I got a new electrode assembly. And as you can notice, that you have to set the gap according to the book. I do 5/32 and 7/16. It's in your book that you reviewed already, and it shows you in this book also here. And I do have a training book that you can check out also, that's in the cabinet by the front door. You can review also. And it'll tell you how to set the electrode assembly and everything. This is where everything takes place here. This will wear out more than anything. The nozzle here, as you can see, there's different types of nozzle. You have to use the appropriate nozzle for that burner that's rated for, and the degree, degree, and also what we're doing here, how much gallons per hour. That's a 0.50, half a gallon per hour, with the 70-degree. See where it says 70, and it's a hollow cone. Remember the 3 types of cones: semi-hollow, hollow, solid. Okay, that's that part, as you can see right here, that goes into there. And that's part of our combustion air tube. Now this is going to be where everything takes place in the burner. This is our transformer, very high voltage. We're going from 120 volts to 10,000 volts right here. Now, very low amperage, it's milliamps. It's almost like a stun gun if you were to hit that thing. It'd be like a stun gun. So be very careful. We always see the contacts on there. These will wear out or the springs will go bad because once it sits on these two electrodes here, remember in that fire tube there? No, the fuel tube, excuse me. It has to sit perfectly on there. As you can see, someone's messed with it a little bit. And it's got to be tight, real tight, and spring up. If it ain't springing up, you ain't hitting them electrodes, or you're hitting something else. So you got to make sure you hit that thing just right. And these will wear out, and I think the next time we're going to get some new ones here. This is our combustion wheel that's down there. As you can see, this motor pump assembly is going to provide combustion air through our tube, combustion air tube, so we can combust. And also we have a pump assembly on it that's going to pump the fuel. We have to bring this pressure up from this fuel because we're sitting here at regular, atmospheric pressure. So we're going to have to increase this pressure to about 100 psig. And remember, you got to go through that nozzle, that little nozzle. So we're going to take that and atomize that fuel. And so we're going to pump it. It's going to come pump through here, and it's going to go through the solenoid valve right here. See where the line comes? The solenoid is going to get energized on a call for heat through our primary control. And it's going to go through this fuel tube all the way to the nozzle. Now, this is the operation part of it. We also have here a CAD cell, photosensitive cell. It's going to look downstream through that tube and pick up the burner light. If it doesn't see burner light through the photosensitive cell, it's going to send a signal here to this primary control to lock out. Now it's 45 seconds on trial for ignition. So let me tell you something. If it doesn't fire up and you reset this, every time you're dumping fuel into this pot. Unlike natural gas or propane gas, it's going to dissipate into the atmosphere. Fuel will sit there, the residual fuel will sit there for a long time. You've been at a gas station where people dump fuel in the gas station. It sits there for a long time. In fact, they got to get absorbent to get this fuel up. If you got a pot full of fuel in here, you're going to have to get all that fuel out before after you correct the problem, restart that, or you're going to have smoke, you're going to have flame going all over the place, and it could be real fun. Believe me, I've been there before. So make sure you take a look inside that heat exchanger. Usually you're going to have a little cover. You can look in there, take an inspection mirror and look around in there. You see a lot of fuel in there. That customer or that has reset that thing quite a few times, not just once or twice. So we understand how the primary control works. We understand how the electrode transformer, CAD cell, pump, combustion air. All right. We got to make sure every time we're down, we're touching that. We want to touch them electrodes. And these got to line up pretty good in here when you put that tube symbol in there. So you got to make sure you're in there. Usually if I don't have any spring in there, I ain't hitting right. And always put your clamps on, you tighten them down. I'll make sure this thing is nice and secure, tight, everything tight. Now this is our thermostat, which operates everything here. Naturally, you understand thermostats. That's our on-off control switch, primary control switch. We're eventually going to set this to heat. It's a electronic thermostat. We're going to set it above the set point to get this thing fired up, and that's going to send the signal to the control board. We're ready to go. It's going to start up the combustion air, and off we go. But I'm going to do a little bit on the fuel now, the most important part. Normally this is a simulated tank, how a tank would be. Most fuel tanks are big and they're outside. Now somebody put a big, it's supposed to be just real hand tight. We want to make sure it's tight. We don't want no moisture to get in there. But I don't want no one, we got to worry about electrostatic discharge. I don't think it's a big deal out here, but it could be. So you want to see where our fuel level is. You can see down as far as you can. You can stick a flashlight, look. I don't have to say it, but no matches or lighters, please. But I made this little fuel stick here like the gas stations use. And we can tell how much fuel we got. And actually it's wood. And I have a little rag here. And remember, we're messing with diesel fuel, so if you got good clothes, you want to work on this thing, I wouldn't recommend bringing your Sunday best. So bring some old clothes. We do have coveralls there. So I'm just going to dip this down in there and find out where the fuel level is. And it's right about there. And I look at it, I'm probably running about quarter of a tank. We don't want to run this too low because like anything else, like running a fuel tank, what's going to happen? We're going to have plugging up this fuel filter right here with all the stuff that's settled to the bottom. And fuel filters, you know, you change regularly, but you know, you could plug these things up if you pump out a tank real quick. So we got enough fuel there. Eventually we're going to have to get some more. All right. We always make sure we put this on real tight. Snug as a bug. Now this is the most misunderstood item on this burner and all gas oil-fired burners. It's a special safety valve. What it is, if this fuel line gets too hot, about 165 degrees, let me take this off, I'll show it to you. As you can see, I can counterclockwise back it all the way out like this. It will open the valve. Now, as you can see, it doesn't operate like a regular hand valve. It's got a soft soldered, which I'll show them a sleeve in there. If it gets too hot, it's going to melt and force that spring to close. But I'm going to open it up all the way to show you how it opens all the way. See how it's opening? I'm putting pressure on that spring now to open that valve so it's all the way open. A lot of guys get this part, they just get confused on how this thing works because it is a firematic valve. Now it's tight, it's all the way open. Now to close it, I go clockwise so I can take this handle all the way off, and I'll show you the inside of the handle. Inside the handle, see that little soft solder? It'll melt at 165 degrees. If it gets that hot, it's going to melt, forcing that spring to slam the valve shut. So it's not broken. Like I said, oh, it's broken. No, it's not broken. So there we go. All right, right now it is the closed position. There's no fuel coming up here. So now I'm going to open up the valve like I did before, all the way open. Going counterclockwise until it's tight. Now you don't have to put a wrench on it. I don't want no wrenches on these valves. None, 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 none. That's how the other one got ruined. So it's all the way right about there. Now we're full open. We're ready to fire this thing up. Before we fire it up, we want to make sure we have no combustible things around the area, no newspapers, none of your books or anything, because this thing's going to take off. It's going to fire up. We're going to do step by step. I'm going to show you the pressure on this thing. Also has it calls for heat. Now I'm going to switch it over to heat, and then I'm going to hit the set point. Above 76. I'm going to go up to 81. Turn on the switch. And we have ignition. Look at the pressure. We're running about 140 pounds of pressure. Usually the minimum is about 100. As you see, we're right there about 140 pounds, which is fine. Now we're pumping, we're also doing combustion air, and as you see, we do have combustion. Got a nice good fire ring on there, all the way around. It's enveloped around. Like I said, you would have a combustion analyzer checking this out. Now, I'm going to adjust this primary air. As you can see, I am moving it wide open. And as you can see, that smoke and that flame over there. See how I'm really... Yeah, you can see the flame, how bad it is right there. Because we're getting too much combustion air. Now I'm going to slow it down and choke that air off a little bit. Now I'm getting a better feather of the flame. I'm getting a good ratio of combustion air and fuel. We want a good fire ring, good quality combustion, and like I said, we need an analyzer to do that. But I just want to show you a little bit on this trainer to get you a little bit more familiar with it. I hope this helps out quite a bit. Feel free to operate this thing as much as you want and ask questions with the instructor. But remember, instructor has to be out here at all times when this is fired up. Okay, thank you very much.